in the previous lecture, we discussed about the classification of elements, compounds, as well as the mixtures. Okay, you know that elements are classified into metals, non-metals, and metalloid elements. And mixtures are classified into homogeneous and heterogeneous type of the mixtures. Now see the states of the matters. You know that matter occupies any space and have the definite mass. Okay, now this matter is exist in three states. You know that these states are solid, liquid, and gaseous state. Matter is exist in three states: solid, liquid, and gaseous state. This solid, when we heated, then it is converted into liquid. While when liquid is heated, then it is converted into gaseous state. Whereas if we cool these gases, then we get liquid, and again if liquid gets cooled, then we get the solid. Okay, that is solid, liquid, and gaseous states of the matter are interconvertible. These states are the interconvertible. म्हणजेच आपण स्थायूचं द्रवामध्ये, द्रवाचं वायूमध्ये उष्णतेच्या साहाय्याने रूपांतर करू शकतो, किंवा वायूला आपण जर कूल केलं तर लिक्विडमध्ये कन्व्हर्शन करू शकतो, लिक्विडला कूल केलं तर सॉलिडमध्ये कन्व्हर्शन करू शकतो. म्हणजे या तिन्ही स्टेट्स काय आहेत? इंटर कन्व्हर्टेबल आहेत. एकमेकांमध्ये सहजपणे रूपांतर करता येतं. ओके, and you know that these solids have the definite shape. They have definite shape as well as definite volume. Solids have definite shape and definite volume. These liquids have not definite shape. These liquids have not definite shape, but they have the definite volume. They have the definite volume. Whereas gases have neither definite shape nor volume. Okay. स्थायू पदार्थांना निश्चित असा आकार असतो, शिवाय आकारमान असतं. द्रव पदार्थांना निश्चित आकार नसतो, पण आकारमान मात्र निश्चित असते. दे हॅव डेफिनाइट व्हॉल्यूम. आणि गॅसेसना मात्र डेफिनाइट शेपही नसतो आणि डेफिनाइट व्हॉल्यूमही नसतो. नायदर डेफिनाइट शेप नॉर व्हॉल्यूम. ओके, remember well that all these three states, either it may be solid, liquid, or gaseous, these are interconvertible states of the matter, and matter have physical as well as chemical properties. Physical as well as chemical properties. कोणत्याही प्रकारचा जर आपण सबस्टन्स घेतला, मग तो स्थायू असेल, द्रव असेल, किंवा गॅसेस स्वरूपामधला असेल, वायू स्वरूपामधला असेल, तर प्रत्येकाच्या भौतिक आणि रासायनिक गुणधर्म या मॅटरला असतातच. मॅटर possess both physical as well as chemical properties. So what are the physical properties? First we discuss. Then we discuss the chemical properties. What are physical properties? The properties which can observed or measured without change in composition. Without change in composition, are called as the physical properties. मॅटरची फिजिकल प्रॉपर्टी म्हणजे काय, त्याचं भौतिक गुणधर्म म्हणजे काय, तर मॅटरचे किंवा त्या पदार्थाचे जे गुणधर्म आपण कंपोजिशन चेंज न करता, मॅटर मधलं जे प्रमाण आहे ते न चेंज करता ऑब्झर्व करतो, त्याला आपण फिजिकल प्रॉपर्टीज म्हणतो. ओके, फॉर एक्झाम्पल कलर, ओडर जे वास, रंग, वास, मॅटरचा मेल्टिंग पॉइंट, बॉइलिंग पॉइंट, द्रवणांक किंवा उत्कलनांक ज्याला आपण म्हणतो ते, डेन्सिटी, घनता, या ज्या सर्व प्रॉपर्टीज आहेत यांना फिजिकल प्रॉपर्टीज असं म्हणायचं. लक्षात, या आपण मॅटरचं कंपोजिशन चेंज न करता हे ऑब्झर्व करू शकतो, म्हणून या फिजिकल प्रॉपर्टीज. ओके, सेकंड, व्हॉट आर केमिकल प्रॉपर्टीज. केमिकल प्रॉपर्टी म्हणजे काय, द प्रॉपर्टीज विच आर मेजर्ड और ऑब्झर्व्ड बाय चेंजिंग द कंपोजिशन, by changing the composition of matter are called as the chemical properties. रासायनिक गुणधर्म कशाला म्हणायचं मॅटरचं, तर जे मॅटरचं कंपोजिशन चेंज केल्यानंतर ऑब्झर्व केलं जातं त्यांना म्हणायचं केमिकल प्रॉपर्टीज. फॉर एक्झाम्पल, इफ यू टेक मॅग्नेशियम पी, and if we heated in the air, then we get magnesium oxide. We get magnesium oxide, that is magnesium plus oxygen, we get twice of MgO, take 2 Mg plus O2, we get 2 MgO. Here magnesium oxide is formed. Here what happened, original composition of the matter it changes and we get magnesium oxide. So this property of the matter is called as the chemical properties. ठीक आहे, म्हणजे तुम्हाला भौतिक आणि रासायनिक गुणधर्म म्हणजे काय हे लक्षात आलं. All matter consist of the physical as well as the chemical properties. These physical properties can be measured or observed without changing composition, while chemical properties are observed by changing the composition. Okay, now next article is units. Units. Okay, युनिट म्हणजे आपण त्याला मराठीमध्ये परिमाण असं म्हणतो. कशाला म्हणायचं युनिट, arbitrarily decided, arbitrarily, or we can say that randomly or arbitrarily decided and universally accepted standards are called as the units. Arbitrarily किंवा randomly याचा अर्थ काय, तर सर्वसाधारणपणे ठरवलेलं, सर्वांनी ठरवलेलं, अँड युनिव्हर्सली ॲक्सेप्टेड, आणि सर्वांनी ते मान्य केलेलं जे स्टँडर्ड्स असतं त्या स्टँडर्ड्सला काय म्हणायचं, युनिट्स असं म्हणायचं. ओके, नाउ द प्रॉपर्टीज ऑफ द मॅटर्स आर मेजर्ड अंडर डिफरंट युनिट्स and there are several systems are available. For example, SI system or called as MKS system or CGS system. Units are measured in SI system that means international systems, or MKS systems means MKS, meter kilogram second, meter kilogram and second, this system, or this centimeter gram second. Properties are measured in either SI or MKS systems or in CGS system, meter kilogram second system or centimeter gram second system. Okay, now some properties or parameters useful in the chemistry and physics are several parameters. For example, length, then we take mass, time, then we take thermodynamic temperature, length, mass, time, thermodynamic temperature. Then also we take the electric current, then amount of substance and luminous intensity. So these are main parameters. You know that length, symbol L, mass M, time T, thermodynamics temperature, so write T, electric current, write I, amount of substance measured in N unit, and luminous intensity CD, or called as candela. Here unit of the length is the meter 1, unit of length is meter, called as M, mass measured in kilogram, called as kg, time measured in the second, yes, thermodynamic temperature is measured in Kelvin unit or denoted by letter K, electric current I measured in ampere or denoted by symbol A, amount of substance N measured in mole and its unit is mole, luminous intensity CD, candela, called as in CD, luminous intensity. Generally it is also denoted as a I. So these are units measured in the MKS system. So combination of these MKS units are also useful for the determine the another quantities or another parameters in different units. These units are called as the derived units. Okay, so these are the MKS system units: length, mass, time, thermodynamic temperature, electric current, amount of substance and luminous intensity. लेंथ म्हणजे लांबी, मास वस्तुमान, टाइम वेळ, थर्मोडायनॅमिक टेम्परेचर म्हणजे थर्मोडायनॅमिकली प्रॉपर्टी जी असेल त्याचं घेतलेलं तापमान, इलेक्ट्रिक करंट तुम्हाला माहिती आहे, अमाऊंट ऑफ सबस्टन्स हा केमिस्ट्रीमध्ये आपणाला महत्त्वाचा युनिट आहे अमाऊंट ऑफ सबस्टन्स मोल. हे आपल्याला कॉन्सन्ट्रेशन वगैरे डिटरमाइन करण्यासाठी परत वापरावं लागणार आहे अमाऊंट ऑफ सबस्टन्स. आणि त्यानंतर ल्युमिनस इंटेन्सिटी म्हणजे तीव्रता, जी कॅन्डल या युनिटमध्ये वापरली जाते, सीडी. ओके, so these are the MKS units. Then we see when these units are combined together, then another quantities are also used to measure some other parameters. These different units are called as the derived units. So the units which are formed by the combination or say dividation of the MKS system units are called as the derived units. Several derived units, near about 11 to 12 derived units are there. We see these derived units as a different one by using these units. For example, area, you know that it is determined by using meter square. Volume is measured using meter cube. Then area meter square, volume meter cube. Density, you know that kilogram per meter cube, kg per meter cube, or gram per centimeter cube. Density is measured. Then pressure is measured kilogram per meter and per second square. Then after pressure can take force, kilogram meter per second square. So these are some derived units: area meter square, volume meter cube, density kg per meter cube or gram per centimeter cube, pressure kilogram per meter per second square, force kilogram meter per second square. Then velocity is measured meter per second velocity. Then acceleration, which is used in the physics article, it is measured in meter per second square, acceleration. Then another some unit, potential difference generally measured in volt, or this potential difference is also measured in joule per coulomb. Volt or joule per coulomb potential difference. Then several another units are also energy, which is present or taken in the form of work or heat, generally measured in the joule unit. Energy is measured in joule unit or joule per second. Then another some units, derived units, are potential difference, energy or work. Also we can write concentration, mole per dm cube or mole d per meter cube, mole per dm cube or mole meter cube. Similarly, another some derived units are chemical equivalent, kilogram per second, heat capacity, measured in joule per Kelvin per mole, joule per Kelvin per mole. Okay, so there are near about 11 to 12 derived units. These units are also very important while we calculating or solving the several problems. You should familiar with these problems, derived as well as the MK system units. Okay, so we stop here. I think energy or work measured in only joule unit. So today we stop here. In next lecture we discuss about the physical properties of the some matter. Energy we can write joule per second. Okay, so we stop here.